Okay, so we're finding the practice exam question 3. So, zipping on down. There we go. Question 3. Another hotel is fully booked with 22 guests during summer. In previous years, 66% of guests had their dinner at the hotel restaurant. So we've got 22 guests and 66% of them are likely to have their dinner at the restaurant. Using an appropriate distribution. The distributions we're thinking: binomial, Poisson, normal, triangular, rectangular, rah-de-rah-de-rah. Calculate the probability that at least 15, so the probability that at least 15, so that means greater than or equal to 15, doesn't it? Guests will eat at the hotel restaurant. Justify your choice of distribution. Identify the parameters of this distribution and state any assumptions you make. So what's the distribution? Yeah. Binomial. Okay. With binomial, what are the conditions? Okay, so bi meant 2 outcomes. And what are the 2 outcomes in context? Eat or not to eat. Okay, clearly you wouldn't write eat or not. You would to eat or not to eat. And that is the question. 2 outcomes. Okay, that's bi. No. Set number of trials. And that's 22 guests that are either going to eat or not eat. Me, myself and I, independence. Assumption is independence. Hang on. Independence. Now, this assumption is somewhat questionable because guests come in groups. So if I went on holiday with my family of 10, all of them are either going to go to the restaurant or none of them are going to go to the restaurant. If I've got a family of 10, I probably can't afford to go out to dinner and pay for a hotel, unless I'm really rich. Anyway, the assumption is independent, so bi is 2 trials. Bi is 2 outcomes. No, a set number of trials. Me, myself and I, independence. And what's the AL for? All. It's constant, isn't it? Constant probability. So constant probability. Okay. So what's our N then? 22, and what's our probability? 0.66. Okay, now what button are we using on our calculator? So we are binomial, continuous distribution. Okay, let's get the calculator out. We go menu, we go to stats, we go to distributions, we go to binomial, we go BCD, and it's variable. Now, with the binomial, we've got a problem, haven't we? X was, if I look at this, greater or equal to 15 is the same as 1 minus the probability of X being less than 15. But with your binomial, is it less than or equal to or less than? It's less than or equal to, so I've got to go less than or equal to 14, don't I? Yep. So I'm going to go 14, and the number of trials 22, and the constant probability 0.66. And so I get that, which I will just grab with my snipping tool. There we go. Grab that and paste it. Okay. Now, I'm going to check I haven't done anything stupid, which is sometimes likely. So, here we have got 1 minus that equals that. So, the 4866 is correct, but I hadn't actually finished. Nice and quiet, please. So I needed to go, and this is very messy, so that equaled 1 minus 0.4866, which equaled 0. And it is 5134. Okay, so that's given us that probability. Now let's check back into our schedule. Fixed number of trials, 22 guests. The in context is the 22 guests. So if you want to get merit, you need to have it in context. Okay? So the 22 guests, rather than just fixed number of trials, that's going from achieved to merit. Fixed probability, 66% probability of eating in the restaurant. Eating in the restaurant is in context. That's jumping you from achieved to merit. 2 outcomes, to eat or not to eat. Again, that's jumping you to merit because it's context. Independence of events. A guest eating at the restaurant does not influence other guests doing so. This is an assumption, possibly an incorrect one. Assumption. Guests will make up their mind independently each day, not based on past experience. That's really important because some people like to eat at the restaurant every night, other people like to eat out every night. Some people a combination. So it's actually, those assumptions are questionable, and that's something that's going to get you excellence in the last question, to actually be aware of that. So probability calculated with identification of probability distribution and parameters. If you want to pass this thing, you have to state these, the parameters are these. So basically probability calculation, you get this correct, you've said binomial and you've said this. Show you're working, you must show binomial, n equals this, p equals that. Probability calculation with identification of probability distribution and parameter, that's the same, and justification of applying this distribution linked to context. Okay? Applying this distribution because. So if you don't link to context, you're not going to get merit. You could list all those outcomes and not get merit because you didn't link it. Okay. Cool. Next question. For 89 days in summer this year, the restaurant kept records of the number of guests who ate in the hotel restaurant each evening. Graph below. Estimate the mean and standard deviation of the number of guests. Right, I'm just going to show you how to not estimate. I think I did this the other day, or was that for the other class? So if you go exit, now we have an outcome of 0, and an outcome of 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Alrighty. Now for the outcome of 0, how many, what was the frequency? 2. It was 2. That's correct because it's going up in 2s. And for 8 was 1, 9 was 1, 10 was 2, 11 was 1, 12 is 4, 13 is 8, 14 is 7, 15 is 2, 4, 6, 8, 9, that's 9, that's 11, that's 13, that's 15, that's 4, that's 1, that's 4, and that's 6. It's just to speed up my entry. So where am I up to? Number 15 was 9, 11, 13, 15, 4, 1, 4, 6. Now, I need to go calc, I need to set, I need to make sure that the frequency is in list 2. Okay, execute, and so now one variable, and I have got n is 89, I've got a mean of 15.9, mean equals 15.9, and the standard deviation of,
is it frequency of days?
hang on a sec, that's 3.9. Okay, so this is the frequency, so that means that 8 guests ate dinner one day, and here 18 out of the 22 guests ate dinner 15 days. So there must have been over 89 days. Oh, there we go. Look at that. For 89 days. So n was 89. So each day, certain number of people ate dinner. Okay? So that's nice. Now let's look at the answer scheme for that. So the mean, 15.9. Standard deviation 3.9. Well done us. If you said anything between 15 and 17, you would get correct. Anything 3 to 5, you get correct. It's actually really not that easy to guess it. You've got to be really statistically aware. It's quicker, I think, almost to calculate it. Estimate the mean or standard deviation is achieved. Estimate both as mirror. Okay? So if you actually just calculate, it's kind of cool, I think. It's all good. Alrighty. So what we've done so far is this here is a model estimate. Okay? Model a formula. It's spitting out the probability. And then this one here is an experimental estimate, an experimental model. So we've got the raw data, we're getting the standard deviation from the raw data. How would you get the standard deviation of this one? Go to your formula sheet. I'll grab my formula sheet. Okay, so formula sheet, here we go. We're going down to find our binomial. So binomial is here. And you can see that the mean is n times pi. So the mean is 22 times 0.66. So you can grab that. 22 times 0.66 is 14.52. And the standard deviation equals the square root of 22 times 0.66 times 0.34, which equals the square root, oh no, just go like that, 22 times 0.66 times 0.34, and then we go to the power of 0.5, same as the square root, you get 2.22. Okay, so if we go back to our answer scheme here, you will see, is anyone still listening to me? Oh, somebody is. Okay, so here n is 22, probability 0.66, mean 14.52, standard deviation 2.22. So mean 14.52, standard deviation 2.22. So that's just come from here. It gives it to you.